For hydrogen-like ion, the radius of the first orbit is 0.1325 angstroms. What is the general formula? Radius of the nth orbit 0.529 into n square by z. Orbit number first orbit. Radius is given as 0.1325. 0.1325 is equals to 0.529 by z into 1 whole square. Simplify. Z is equals to 0.529 divides with 0.1325. Simplify. Z value is equals to 4. So atomic number 4, correct. The ion is beryllium 3 plus. This is also correct. Energy of the electron in the ground state. Energy of the nth orbit formula minus 13.6 into z square by n square. Minus 13.6 into z value 4 calculated. N value 1. Simplify. Minus 217.6 electron volts. Yes, this is also correct. Velocity of the nth orbit Vn is equals to V by N into Z. So V by 1 into 4, that is equals to 4V. But here given 2V, so incorrect statement, fourth statement. An electron is accelerated through 150 volts potential difference. Which of the following statement is incorrect? First of all, incorrect statement. Okay. The relation between wavelength and potential difference V is lambda is equals to square root of 150 by V. So square root of 150 by 150, that is equals to square root of 1. Square root of 1 value is equals to 1. But here de Broglie's wavelength 1. Here given as de Broglie's wavelength 1.5. This is only incorrect. Remaining statements once check it. Momentum of electron increases with voltage. Momentum of electron P is equals to what we know according to de Broglie's square root of 2 into m eV. So momentum is directly proportional to square root of potential, directly proportional only. Wavelength decreases if voltage increases. What is the relation? Lambda is inversely proportional to square root of V. Wavelength depends on electron mass. We know that lambda is equals to h by square root of 2 into m eV. Remaining statements correct. Only first statement wrong. Which of the following statement is incorrect regarding Fuzzen's rule? Regarding Fuzzen's rule, incorrect statement. Smaller cation increases covalent character. Correct. Smaller cation increases covalent character. Fourth statement incorrect. Larger cation increases covalent character. This is wrong. Larger cations increases ionic character. Which of the following species is diamagnetic? Calculate total number of electrons. Even number, diamagnetic. Except in case of 10 electrons and 16 electrons. 10 and 16 are even numbers only, but these are paramagnetic according to MOED diagram. Here total number of electrons 15, here total number of electrons 17, here total number of electrons 16, here total number of electrons 18. So diamagnetic. Which of the following statement about hybridization is incorrect. Hybrid orbitals formed by mixing of atomic orbitals of comparable energy is correct. Number of hybrid orbitals formed is equals to the number of atomic orbitals mixed. Correct. All hybrid orbitals formed are identical in energy and shape. This is also correct. Incorrect statement. Hybridization occurs only after bond formation, not after bond formation. Occurs before or during bond formation. When 4 grams of hydrogen reacts with 32 grams of oxygen to form water, which of the following statements are correct? Check it, any limiting reagent is present or not. How to calculate limiting reagent? Number of moles divides with the stoichiometric coefficients. Stoichiometric coefficients. So number of moles, weight by molecular weight. Weight of hydrogen is 4 grams. Molecular weight of hydrogen 2. 32 by 32. 2, 1. Number of moles. Now divides with stoichiometric coefficients. 2 by 2. 1 by 1. 1, 1. So here there is no limiting reagent. First statement wrong. Second statement also wrong because both are equal. 36 grams of water is formed. Check it. Water 2 into water molecular weight 18. 36 grams of water is formed. Correct. 36 grams is water is formed. There is no limiting reagent. That's the reason no reactant remain after the reaction. This is also correct. So C and D are correct. Balance the following reaction. MnO4 minus converted to Mn2 plus. Fe2 plus is converted to Fe3 plus. First calculate N factor values. Oxidation state is plus 7 here. Here plus 2. Oxidation number difference 5. N factor value is also 5. X is equals to plus 2. X is equals to plus 3. Oxidation number difference 1. N factor value is also 1. Now exchange the coefficient. 1 mole of MnO4 minus plus 5 moles of Fe2 plus you can take. The first option is look like that only. Now check it. Manganese atoms balanced, oxygen atoms balanced, irons balanced, hydrogens are also balanced. Now check the charge. Reactant total charge minus 1 plus 2 into 5, 10 now plus 8 minus 17, sorry plus 17 reactant side. Product side plus 2 plus 15 plus 17. Everything is balanced. So the correct option first. Given delta H value 40 kilojoules. Kilojoules converted to joules 40,000 joules. Delta S value 80 joules. At what condition will the reaction become spontaneous? What we know, delta G is equals to delta H minus T delta S. So if you want, remember, set delta G value 0 to find exact point where spontaneity begins. 0 is equals to delta H minus T delta S. Delta H is equals to T delta S Temperature is equals to delta H by delta S. Simplify. 40,000 by 80. That is equals to 500 kelvins. Temperature 500 kelvins. Question is related to spontaneous. Temperature is above 500 kelvins, then the reaction is spontaneous. Above 500 Kelvin means at high temperature. For example, temperature take it as 600 kelvins. 40,000 minus temperature I assumed as 600 kelvins into 80. 40,000 minus 48,000. Then you will get negative answer. Delta G value negative, the reaction is spontaneous. So second option correct. A gas expands against a constant external pressure of 2 atmosphere from 5 liters to 8 liters. The work done in liter atmosphere. W is equals to minus P external into delta V. Minus 2 into delta V means nothing but V2 minus V1. So final volume 8, initial volume is 5 liters. Minus 2 into 3, that is equals to minus 6 liter atmosphere. Remember here 1 liter atmosphere is equals to 101.325 joules. Consider the equilibrium. Which of the following will shift equilibrium to the left side? Equilibrium to the left side. First of all, check it. Left to right. This is solid. This is solid. This is gas. That means number of gas particles are increases. 0 gases are converted to 1 gas. Number of moles are increases. Initially 1 mole, here 2 moles, or gas moles here 0, here 1 mole. So number of moles are increases, volume increases. We know that volume is inversely proportional to pressure. So low pressure favors actually. But suppose low pressure favors for this reaction. On increasing pressure, equilibrium shift towards left side. Adding more CaCO3, no use because CaCO3 is solid. Removing CO2, remove CO2, removing CO2. Removing CO2 means products. Removing product. Removing product. Products are decreases. Then equilibrium shift towards right side. Towards right side. So remove this option also. Decreasing temperature. Decreasing temperature. So this is a endothermic reaction. This is the endothermic reaction. Delta H is equals to HP minus HR. Gases products 1, gases reactants 0. You will get positive value. It is a endothermic reaction. Endothermic reaction, low temperature favors. Generally, endothermic reactions, high temperature favors. Reactants requires heat, high temperature favors. But here what is doing? Decreasing temperature. High temperature favors. Suppose if you can decrease the temperature, equilibrium shift towards left side. So A and D are correct. The pH of a solution obtained by mixing 50 ml of 0.1 molar CH3COONA. CH3COONA is salt. with 50 ml of 0.1 molar CH3COOH acid. Calculate the pH. pH is equals to pKa plus log of salt concentration by acid concentration. Ka value is given 2 into 10 power minus 5. pKa is equals to negative logarithm of Ka. Negative log of 2 into 10 power minus 5. 5 log 10 minus log 2. 5 log 10 value 5, log 2 value 0.3010. 5 minus 0.3010, 4.6990. pKa value 4.6990 plus log of salt concentration 0.1, volume is 50, 0.1 into 50 by 0.1 into 50. Cancel log 1 value 0, then 4.6990 is the pH. This is nearly equals to 4.7. A solution contains 0.01 molar Cl minus 0.01 molar I minus. When AgNO3 is added slowly, which salt will precipitate first? First of all, Asp of AgCl is equals to Ag plus concentration into Cl minus ion concentration. Ag plus ion concentration is equals to Ksp of AgCl by Cl minus ion concentration. Ksp of AgCl is 1.8 into 10 power minus 14 given. Cl minus ion concentration is 0.01 means nothing but 10 power minus 2. Simplify, then you will get 1.8 into 10 power minus 12. Ksp of AgNO3, AgI, not AgNO3. Ksp of AgI is equals to concentration of Ag plus into concentration of I minus. Calculate the concentration of Ag plus in AgI. Ksp of AgI by I minus ion concentration. 3.6 into 10 power minus 17 by 10 power minus 2. Simplify, 3.6 into 10 power minus 15. Now observe the point here. In AgI, Ag plus ion concentration is low compared with the Ag plus ion concentration in AgCl. That's the reason AgI precipitate first. Which salt will precipitate first? Ag plus ion concentration in AgCl. AgCl is more compared with Ag plus ion concentration in AgI. Ag plus ion concentration in AgI is low. That's the reason it precipitate first. The vapor pressure of pure benzene is 100 mmHg and that of toluene, this is benzene 100 mmHg, toluene is 40 mmHg at a certain temperature. A solution contain 1 mole of benzene and 1 mole of toluene. The total vapor pressure of the solution is total vapor pressure P total is equals to P naught A XA plus P naught B XB. A represents benzene and B represents toluene. That is equals to P naught A, vapor pressure of benzene 100, into mole fraction of benzene, number of moles of benzene by number of moles of benzene plus number of moles of toluene, plus vapor pressure of toluene 40, 1 by 1 plus 1, 100 by 2 value is 50, 40 by 2 value is 20, that is equals to 70 mmHg. Third option correct. The osmotic pressure of 0.1 molar KCl solution at a certain temperature is found to be 4.5 atmosphere, whereas the osmotic pressure of 0.1 molar glucose solution at the same temperature is 2.5 atmosphere. The want half factor of KCl is approximately. Calculate the want half factor of KCl by using the given data. First of all, what is the formula? Osmotic pressure pi is equals to ICRT. Now, for glucose solution, pi value is given as, osmotic pressure value is given as 2.5 atmosphere. Glucose dissociation is not possible, so want half factor value is equals to 1. What is the concentration of glucose? 0.1 into RT. Temperature is not given. R value is also R only. Then RT is equals to 2.5 by 0.1, that is equals to 25. Now for KCl solution, pi is equals to ICRT, I is equals to pi by CR. For KCl solution, what is the pi value given? 4.5. Concentration 0.1. RT value is calculated, that is 25. 0.1 into 25. Then 4.5 by 2.5. Simplify, you will get 1.8 approximately. When the same quantity of electricity is passed through Ag plus Cu2 plus and Al3 plus solutions, which metal will be deposited in maximum? If we can pass 1 Faraday of current, 1 by k moles of the substance is deposited. We can pass 1 Faraday of current through Ag plus, then 1 by, what is the charge? Plus 1. 1 by 1 mole of Az is deposited. If you can pass 1 Faraday of current to Cu2 plus, 1 by 2 moles of copper is deposited. If you can pass 1 Faraday of current through Al3 plus, then 1 by 3 moles of aluminum is deposited. Now question is, which metal will deposit maximum? 1 mole of silver weight. 1 mole of silver weight is 108. 1 mole of copper is 63.5 by 2. Aluminum 27, 1 mole by 3. So correct answer is silver. Which of the following statement about limiting molar conductivity is incorrect? So see, molar conductivity increases with decrease in concentration. Question is incorrect. Fourth one is incorrect. It increases with increase in concentration. Wrong. It increases with decrease in concentration. Why? Once read this paragraph. E0 cell is equals to 1.1 volts. N is equals to 2. The equilibrium constant K approximately. According to Nernst equation, E is equals to E0 minus 0.0591 by N log K. Calculating equilibrium constant. So reaction is in equilibrium. At equilibrium, the value of E is equals to 0. E value is equals to 0. then E naught is equals to 0.0591 by n log k. Then log k is equals to E naught into n by 0.0591. What is the E naught value? 1.1 into 2 by 0.0591. Simplify, then you will get 37.225 log k value. Then k is equals to 10 power 37.225, approximately 10 power 37. The half life period of a first order reaction is 6.93 minutes. The time required for the completion of 99% of the chemical reaction will be. For first order reaction, this is the relation. So based on this, T 90% is equals to T 99% by 2. This is equation 1. This is equation 2. From equation 1 and 2, T 99% by 2 is equals to 10 by 3 into T 50%. T 99% is equals to 20 by 3 into T 50%. T 50% value is given as 6.93. 20 by 3 into 6.93. 3 twos, 3 threes, 3 ones. 20 into 2, 40. 46.15 nearly. For reaction A gives rise to B, the rate constant K1 is equals to A1 into e power minus EA1 by RT, and for the reaction P gives rise to Q, the rate constant K2 is equals to A2 into e power minus EA2 by RT. If A1 is equals to 10 power 8, A2 is equals to 10 power 10, EA1 600, EA2 is equals to 1200, then temperature at which K1 is equals to KT is K1 is equals to K2 condition. If K1 is equals to K2, then A1 into e power minus EA1 by RT is equals to A2 into e power minus EA2 by RT. Now A1 value is given. A1 value is 10 power 8 into e power activation energy minus 600 by RT is equals to 10 power 10 into e power minus 1200 by RT. Now it can be also written as 10 power 8 term shifted to right side. Then e power minus 600 by RT whole divides with e power minus 1200 by RT. RT is equals to 10 power 10 by 10 power 8. Simplify now. E power reciprocates 1200 minus 600 by RT is equals to 10 square. E power 600 by RT is equals to 10 square. Apply ln on both sides. Apply ln on both sides. Apply ln both sides. Then ln e power 600 by RT is equals to ln into 10 square. Ln e cancel. 600 by RT is equals to 2 ln 10. We know that 1 ln is equals to 2.303 log. So 600 by RT is equals to 2 into 2.303 log 10. So log 10 value is equals to 1. Log 10 value 1. Now RT is equals to 600 by 4.606. T is equals to 600 by 4.606 into 6 into R. Based on that, third option correct. Which cation gives white precipitate with NH4Cl, NH4OH plus NH4 twice CO3? NH4 twice CO3, barium, strontium, calcium. This is the group 5 reagent. So based on that, first option correct. Assertion. For the titration of NaOH versus H2C2O4, methyl orange is used as indicator. Wrong. Why it is wrong? Because NaOH is strong base. If base is stronger, then use phenolphthalein indicator. pH range of NaOH versus H2C2O4 titration is 3 to 6. This is also wrong. pH value is more than 7, greater than 7. Why? NaOH is strong base. Both A and R are false. Which of the following represents incorrect trend for the mentioned property? First ionization potential, fluorine greater than, phosphorus greater than, sulfur greater than, boron. Correct. Electron affinity, chlorine greater than fluorine greater than, sulfur greater than, phosphorus. This is also correct. Metallic character, incorrect order. The correct metallic character is potassium greater than, magnesium greater than, aluminum greater than, boron. In period 4, nitrogen, lithium, sodium, potassium. Period 4, 1A group is potassium. Helium, neon, argon, krypton. Period 4, ending element is krypton. Fluorine, chlorine, bromine. Okay. In period 4 of the periodic table, the element with highest and least atomic radii, there is no krypton, so neglect. Correct answer, highest is largest, highest potassium, lowest bromine. First option. State given as propanol, meth, eth, propanol, propanone, meth, eth, propanol and propanone functional isomers. Correct. Ethoxyethane, C2H5O, C2H5, methoxypropane, CH3O, C3H7 are metamers. Correct. But1ene shows geometrical isomers. Meth, eth, but1ene no, does not shows geometrical isomers. Wrong statement. But1ene and but2ene are position isomers. Correct. Position of double bond is different. Pentane, meth, eth, but-pentane, 2,2 dimethyl propane are chain isomers. Correct. A, B, D, E. Second statement correct. When 1 gram of organic compound is subjected to Geldal's method for estimation of nitrogen, 30 ml of 1 normal H2SO4 was neutralized by ammonia evolved. The percentage of nitrogen. Geldal's method, percentage of nitrogen 14 by 1000 into normality into volume of acid by weight of organic compound into 100. 14 by 1000 into normality 1, volume 30, weight of organic compound 1 into 100. 0, 0, 0, 0, 0, 0 cancel. 14 into 3, 42%. Fourth option correct. IUPAC name of the compound. This is look like RCOOR, ester. Ester, IUPAC name, alkyl alkanate. Alkyl alkanate, ethyl. Name starts with ethyl. 1, 2. Second position chlorine. Ethyl 2 chloro. 3, 4. Fourth position double bond. Second option correct option. Assertion C6H5 here nothing but CH3. Toluene is stable than this compound, tertiary butyl benzene. Toluene is stable than tertiary butyl benzene. Wrong. We know that toluene is electron donating group. Tertiary butyl is also electron donating group. Which is strong electron donating group? Size of alkyl group increases. Size of alkyl group is directly proportional to electron donating nature. So tertiary butyl benzene is more stable than toluene. So assertion wrong. Rate of electrophilic aromatic substitution is more in toluene when compared to tertiary butyl benzene. Correct. Why? Toluene, benzyl carbon. Here this is the benzyl carbon. Benzyl carbon contains 3 hydrogen atoms. Here benzyl carbon does not contain hydrogen atoms. Alpha hydrogen atoms are present, more stable. Alpha hydrogen atoms are absent, not stable. That means the rate of electrophilic aromatic substitution is more. Aromatic substitution, electrophilic aromatic. Hydrogen atoms are present, electrophilic aromatic substitution is possible. Here hydrogen atoms are absent, electrophilic aromatic substitution is absent. Assertion wrong, reason correct. Benzene reacts with bromine in the presence of Lewis acid. Process is bromination, halogenation. Bromination, and it gives bromobenzene. It gives bromobenzene. So bromine is electron donating group. Substituted benzene, the substitute is electron donating group with respect to resonance effect. Undergoes nitration. Then it gives major product para-nitro bromobenzene. Minor product ortho-nitro bromobenzene. Phenol undergoes nitration. Then it gives orthonitrophenol, major product. Orthonitrophenol is major. In the previous case, para is major, but here ortho is major. Why ortho is major product? Because here hydrogen bond is possible due to hydrogen bond. And para-nitrophenol. Para-nitrophenol is minor. Okay. No. See, E is more acidic than D. This is E, this is D. E is more acidic than D. Correct. Why? Due to presence of hydrogen bond, orthonitrophenol does not releases H plus ions. Here hydrogen bond is absent. It releases H plus ions. Releases H plus ions. Compound which releases H plus ions, the compound is acts as acid. NO2, second statement, NO2 is para with respect to OH in E. Correct. NO2 is para with respect to bromine in C. Wrong. NO2 is para with respect to OH in D. This is D. Wrong. Only first and second statements are correct. Third option correct option. Reaction is given 1, 2, 3, 4 carbons. This is butane, neath, eth, prop, butane. Terminal alkyne, acidic hydrogen atom is present. So it reacts with NaNH2. Then it gives, first of all, CH3CH2, C triple bond, C, ammonia molecule is eliminated, remove ammonia, ammonia gas is eliminated, C minus Na plus. Okay, now it reacts with isopropyl, where bromine, bromide, meth, eth, prop, isopropyl bromide reacts with isopropyl bromide, C, Br, CH3, CH3. Isopropyl bromide, then it gives CH3, CH2, C triple bond C, CH attached, remove NaBr. CH contains two CH3 groups, CH, CH3, CH3. This is A. Now A reacts with the H2 by nickel. H2 by nickel, reduction takes place. Alkynes undergoes reduction. Then it gives alkane. CH3, CH2, 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 CH, CH3, CH3. A is, check the name of the A. 2-methyl, meth, eth, prop, but, pent, hex. Hex 3-ine, correct. B, 2-methyl hexane, correct. Both A and B are correct. Only A is correct. Third option is correct. Consider the following compounds. Arrange the following compounds in the increasing order of reactivity with nitration mixer. First of all, nitration mixer. It is a electrophilic substitution. Reaction with HNO3, H2SO4. Electrophilic substitution is directly proportional to electron donating group and inversely proportional to electron withdrawing group. Directly proportional to plus I effect, inversely proportional to minus I effect. So identify the groups. OCH3, electron donating group, OCH3, strong resonance group. NO2, NO2 is electron withdrawing group, minus R group, minus I group. Chlorine plus R minus I. Okay, this is plus R plus I, C highest and B lowest, B less than A less than C. Identify the correct statements. First, complete the reaction. Alkene HBr. Alkene HBr follows Markovnikov's rule. Add hydrogen from HBr to unsaturated carbon which contains more number of hydrogens than CH3, CHBr, CH3. Next, bromine in the presence of sunlight. Bromine in the presence of sunlight. Here allyl carbon atom is present. Allylic substitution favors. Then it gives CH2Br, CH, double bond CH2. Next, HBr peroxide. HBr peroxide follows anti-Markovnikov's rule. Then the product is CH3CH, Br, CH2CH3. HBr follows Markovnikov's rule. CH3, CH2, CHBr, CH3. What is given first statement? A and B are isomers. A and B are isomers or not? No, not isomers. This is A, this is B. A is alkane, B is alkene. First statement wrong. C and D are similar compounds. Yes, this is 2-bromo butane. This is also 2-bromo butane. C and D can show optical activity. Correct. How it shows optical activity? This is chiral carbon. Chiral carbon atom is present, optical activity. Among A, B, C, D, rate of SN1 is more in B. SN1, allyl. Rate of SN1 is more in B, correct, because this is on removing bromine, allyl carbocation is formed, correct. Second, third, fourth is correct. That means second option. Order of SN1. Order of SN1 is benzyl greater than, allyl greater than, 3 degree greater than, 2 degree greater than, 1 degree carbocation greater than, methyl greater than, vinyl greater than, aryl. Assertion. In the conversion of an alcohol to alkyl iodide, H2SO4 cannot be used along with Ki. Correct. Because H2SO4 acts as strong oxidizing agent. H2SO4 converts Ki to KHSO4 and HI. HI is further oxidized to I2. Correct. Both A and R are true. Reason is the correct explanation of A. See the chemical reaction. First Ki reacts with H2SO4. Then it gives KHSO4 plus HI. H2SO4 strong oxidizing agent. That's the reason HI further oxidized with H2SO4. Then it gives I2 plus SO2 plus 2 moles of H2O. A and B in the above reaction. What is formed? Alcohol is formed. Which type of alcohol? 1 degree alcohol. 1 degree alcohol is the product. Then reactant is formaldehyde. Formaldehyde, where it is? Here formaldehyde present. Here also formaldehyde is present. Formaldehyde reacts with Grignard reagent. Check it. Formaldehyde HCHO reacts with Grignard reagent C6H5, sorry, cyclohexane MgBr. So break the bond between carbon and oxygen. Oxygen negative charge, carbon positive charge. Carbon negative charge MgBr gets positive charge. Then it gives HCH ring OMgBr, which on further hydrolysis H plus OH minus. Remove MgOHBr. Remove MgOHBr. Then it gives CH2OH. Arrange the following compound in the increasing order of pKa. Ethanol is given. Orthocresol is given. Phenol is given. increasing order of pKa, phenol less than orthocresol less than ethanol, C less than B less than A. What is the question? Increasing order of their pKa. C less than B less than A. I think this is less than symbol. Fourth option correct. How it is? No need to by heart these values. pKa value inversely proportional to acidic nature. First of all, this is aliphatic. These two are aromatic. Aromatic alcohols are acidic than aliphatic alcohols because aromatic alcohols case what is possible? Resonance is possible. After that, acidic nature inversely proportional to electron donating group. Conversion A to B, B to C and C to D follows. Okay, first of all, KMnO4 strong oxidizing agent, oxidation favors. Oxidation favors. Copper by 573 kelvins. Copper by 573 kelvins, 1 degree and 2 degree alcohols. If the alcohol is 1 degree, 2 degree alcohol, dehydrogenation process takes place. Dehydrogenation process takes place. If the alcohol is 3 degree alcohol, then product is alkene. Product is alkene and dehydration process takes place. Alkene reacts with HBr, then that is electrophilic addition. Electrophilic addition. So starts with oxidation, ends with electrophilic addition. So neglect second option or fourth option. Oxidation, copper not acts as reducing agent. Dehydrating agent. If the alcohol is 3 degree alcohol, it acts as a dehydrating agent. Identify incorrect set. Identify incorrect set. Incorrect set is third one. CHO, benzaldehyde. Benzaldehyde participate in Cannizzaro reaction. Benzaldehyde participate in Cannizzaro correct. Benzaldehyde can undergoes hydroform reaction. Wrong. Benzaldehyde does not undergoes hydroform reaction because methyl group is absent. Benzaldehyde can give Tollens test. Benzaldehyde gives Tollens test is correct. Benzaldehyde not gives iodoform test. So that's the reason third option. The IUPAC name of succinic acid. Succinic acid IUPAC name is butane dioic acid. Which of the following is more reactive towards nucleophilic addition? Which of the following is more reactive towards nucleophilic addition? Nucleophilic addition. First of all, aldehydes are more reactive towards nucleophilic addition compared with ketones. By nucleophilic addition reactions, directly proportional to electron withdrawing group, inversely proportional to electron donating group. And one more, aliphatic aldehydes are more reactive towards nucleophilic addition compared with aromatic aldehydes. Acetophenone, aromatic. Vanillin. Vanillin is obtained from vanilla beans. Pleasant fragrances. Once check the NCRT. NCRT aldehyde ketone structure is given. Salicylaldehyde, aromatic aldehyde, crotonaldehyde, aliphatic aldehyde. So fourth option correct. Observe the following compounds. How many of the above can give carbylamine reaction? We know that aliphatic aromatic primary amines gives carbylamine test. First of all, check it. Aniline. Aniline is 1 degree primary only. Orthotolidine. Orthotolidine is also primary amine only. Allylamine. Allylamine. Allylamine is also primary amine only. 2 degree butylamine. 2 degree butylamine. This is the structure. 1, 2, 3, 4. 2 degree butylamine. This is also primary amine. Trimethylamine. Trimethylamine is 3 degree amine. Ethyl methylamine is 2 degree amine. So trimethylamine does not give so ethyl methylamine does not give so. Isopropylamine, yes, isopropylamine is 1 degree amine gives. So how many gives? 1, 2, 3, 4, 5. Second option correct. CH3CONH2, bromine NaOH, Hoffman bromamide reaction. Then it gives primary amine. The product amine contains one carbon atom less compared with reactant. In the above conversion X to A, the percentage of nitrogen. Calculate the percentage of nitrogen. First CH3CONH2, molecular weight of CH3CONH2 59 gram per mole. CH3NH2, molecular weight calculate 31 gram per mole. First of all, X, percentage of nitrogen in X is equals to nitrogen weight 14 by 59 into 100. Simplify, then you will get 23.7%. In A, percentage of nitrogen 31 by, not 31, 14 grams nitrogen weight, 14 by 31 into 100. 1400 by 31, 45.1%. So increases, percentage of nitrogen increases. Hydride given by first element of which group has both melting point and boiling point highest in a respective group. Check it. 7A group, first check the 7A group. Melting point value low, HF melting point value is low. So 7A group ruled out. Now check the 6A group. Melting point value, H2O melting point value is more, as well as H2O boiling point value is also more. So first element H2O melting and boiling point values are high. 7A group, 5A group, once check it. Melting point value is high, but boiling point value, BiH3 boiling point value is high. No doubt, oxygen family. Stability of oxides formed by halogens respectively are iodine greater than, chlorine greater than, bromine. Second option. 3D series with highest melting point comparison between chromium and vanadium only. Among chromium and vanadium melting point value is more. Highest melting point, chromium and vanadium, chromium melting point is more. Highest enthalpy of atomization, vanadium, chromium, vanadium. Fourth option correct. Cr2 plus strong reducing agent than Fe2 plus. Cr2 plus strong reducing agent than Fe2 plus. Correct. Because Cr2 plus SRP value is low. Oxidation takes place, acts as strong reducing agent. D4 to D3 occurs in case of Cr2 plus to Cr3 plus, but D6 to D5 occurs in case of Fe2 plus to Fe3 plus. Both assertion and reason are correct. Reason is the correct explanation of assertion. IUPAC name of the following complex. What is the IUPAC name? Diamine silver 1, dicyanido-argentate 1, diamine silver 1, dicyanido-argentate 1. Third option correct. Thank you.